So, okay, so in the previous 2 days we discussed about the fundamentals behind the machine learning and the processes that basically involve for solving most of the machine learning or you can say AI problems. Right. So, mostly we are moving ahead the learning problems where you have a data, you want to learn certain patterns, right. So, in that direction nowadays you know that many models are available and most of the models are available on cloud through apps or you can say on web portals. You just go, you send, you put your data, upload your data, they will basically analyze your data, they will train your model and they will send it back to you. So, those are commercial models. So, they train your model, they will send back to you the executables or you can say only the model interface, so that you cannot get the access to the parameters or the architectural information of the model. Right. Only the thing you can do that like a device you have input and output system. So, you just send your data, real time data, you will get the response. So, all other things about the model like its architecture, how many parameters, what are the parameter values, all are basically hidden to the client. So, this setting we call black box setting. So, model is in black box paradigm. So, where we do not give access to access the parameter of the models, right. Only what you can do, you have input interface, output interface, you can send your data, you can put your data at input interface, you can get output. And because input interface is fixed, so you know that fixed dimension input you can put. And this is true for all the models, right. So, your schema or you can say the design must be fixed, number of features or the dimension of the input must be fixed. There are some cases where we have recurrent architecture, recursive models. Recursive in the sense that they basically take the data one by one. For example, you have a text classification process, text data. So, you have a many words. So, few sentences might have 5 words, few sentences might have 10 words, 20 words. So, one way is to either you can make it fixed dimension using TF, IDF or some other stories, or you say that okay, you can represent your words, your tokens as a vector. You might have heard the name word vector embeddings. So, you just send word by word and recursively update the parameters, so that it can learn the contextual or you can say positional information, and recurrent neural network are one of the models that were used. And you do not fix the length of the data at that point, but the dimension, input dimension of the architecture is by design it is fixed. So, when you are designing the architecture, so you have to fix the dimensions. For example, word vector embedding we are using, I said that you have word as a vector. So, every word will have the same length, right. So, by the way, the input interface that we have in all the models, it is fixed, and that is basically corresponding to the dimension of your input. So, or you can say the dimension that you have used for training the model. Even in deep learning, people say that deep learning you don't need data pre-processing much, but of course, you need data pre-processing because it needs fixed dimension input, and your model has to basically abide by that particular philosophy. So, your input design must be fixed, right. So, based on the input interface, you have to map your data which can align with that, otherwise you cannot be able to send the data, or you can not able to feed the data to the model for response, or you can say for output. That we have already studied, and few basically in order to learn we have certain objectives. For in SBM we have to maximize the margin. If you go to neural network, so you have ground truth, maybe you can say yi, for example, in SBM we have taken, and you have predicted value, maybe you can call it yi dash or yi cap. So, just try to compare both predicted output and true, or you can say ground truth. You just see that if they are in agreement, then there is no error. But if they are in disagreement, you can say you have an error. So, how can we design the error or you can say loss functions? So, generally you say that we have to minimize this error. So, disagreement we have to minimize. And in the learning theory we have already discussed that what might be the bound on the disagreement. So, epsilon you can define. You say that okay, we can allow only 1% of error. Now, just tell me that what architecture, what other things you need, how many samples do you need. So, that estimate you can roughly you can get. So, that the error that I said that that you can just somehow analyze, you can just think philosophically, but in practice the data that we have that does not follow the assumptions that we have used in pack learning, right, yesterday. So, that says that your sample must be IID, and in practice we do not have such samples. Right. So, that is the reason we are not able to get enough some number of samples which can be representative for the data or you can say distribution, underlying distribution. Right. So, that space we discussed right yesterday. You can see here. So, there are many samples, right. Just see here. There are many samples that are lying outside this rectangular, say you can say this one. So, only we have reached this S, right. So, you can say this block, rectangular block, and there are many more samples which are not in our hand. So, we try to somehow mimic this distribution given this only these many samples, rectangular samples. Right. So, that is the reason we have error when we are developing the model, we have error. And we know that what is the relation between number of samples, confidence, and this error, true error you can say epsilon, or you can say real time error. Right. So, in today's session, so we will discuss more about the attacks, attack spaces, right. But maybe I think before that, have you played that neural network architecture, the link I said, right. Maybe I can just share it first. So, t-test and all other tests are basically significance tests. So, they are just used to tell you that how significant your result is. So, if you are given two vectors and your aim is to identify how much close these two vectors are and how significantly different these two vectors are. So, generally these statistical tests say that okay, they want mean should be in agreement. So, if mean of two vectors are in agreement, we call it null hypothesis, right. And generally we say that null hypothesis violates. So, it means that the mean of the two distribution are totally different, right, significantly different. Otherwise, maybe one mean has 2.0, another mean is 3.0. So, is it significantly different? So, you can think about the vector length that you have, two vectors, and the values that are basically distributed there. So, you can compute the t-test or all Wilcoxon tests, rank tests, right. So, there are many significance tests. You just compute the value, and there is a component we call it p value. So, if p value is basically less than the confidence that you have, basically inverse of the confidence, we call it alpha, right. There you might have seen the basically symbol alpha for that, but delta, the same role is playing here, delta, right. So, delta is same as alpha in that significance test. So, if let basically p value is 0.05, right. So, your significance is you can say 0.05 and confidence is 95%, 1 minus 0.05. So, your confidence is 95%. So, with 95%, if you want to get this null hypothesis or agreement, so you have to apply that test. So, just statistical computation, and if p value comes below that basically universe of significance, or you can say that one, if your p value comes 0.04, let 0.04 is less than 0.05. So, you can say that mean are different, mean of two vectors are different. So, suppose this is very important question he asks. So, many times you have many algorithms to compare. You have a data set, you have 5 algorithms, you have applied models, and you have found the accuracies. Now, you have to tell your model is better, right? Whatever you have proposed is better. So, how will you do it? So, the idea is you run experiments maybe 10 times, 20 times, 100 times. So, every run of the experiment you have accuracies. Right. So, for every model you have 100 such accuracies. Right. So, every time you execute, re-execute, I am not saying that you have to increase the epochs. For all epochs you have to re-execute, right. You will get some accuracies. For other model also the same thing, just compute the pairwise significance test p value, and you can say that if your p value for your model with other model is less than whatever significance you have fixed, your mean is totally different. So, it does not say better, it says different, significantly different. So, if mean accuracy is higher than the other mean accuracy, and your statistical test says that it is significantly different, then you can say that your model is significantly better, right. So, because this t test and other tests basically they follow the philosophy of null hypothesis. They say that okay, if the mean are in agreement, then null hypothesis is proven. So, it says that two distribution has a similar mean. So, there is no much different. So, that is used, right. So, okay. So, this thing we discussed already, right. Maybe if you have any question from previous 2 sessions, please tell me. So, here we have unsupervised learning approaches. So, you people are aware of this one, maybe I can see that if we can play something. So, this is how clustering algorithm basically works, right. K-mean clustering, right, you can see here. You have 4 clusters to assign this data to 4 clusters. So, this is user defined parameter. So, you can say 4 clusters, 5 clusters, 6 clusters, because a priori you do not know. So, what people do? People try iteratively. So, you can start with 2, so you cannot start with 1 because you can say that this is trivial case, right? All members are belongs to one cluster. So, just apply K-means algorithm, you will see that how will it happen and how the mean squared error, can say sum of squared error within cluster and intra cluster and inter cluster, you can just see that how is it varying. So, this is the basically criteria we generally use in clustering. So, Lauti index, right, rand index. So, many metrics we use in clustering, right. But there are challenges also, right. So, maybe you can play this one. Can you see here only 3 clusters were identified, right. It depends because the cluster centers that you are choosing, the cluster basically initialization that you are doing for the K-means clustering algorithm. So, that basically depends that basically drives the whole optimization process. So that's why people use random. So if you have if you want to basically identify 4 clusters, then you just identify 4 means, right? Means is basically center we try to find out. Then later on the algorithm also process with the same thing like mean you have to identify. So whatever members are closest to this cluster, a particular cluster mean, you assign that particular sample to that cluster. So that's the idea in K-mean clustering. Once it is assigned, you just try to identify the within cluster sum of squares. This is one of the metric we try to minimize. This is another clustering. So I think everyone knows hierarchical clustering. So it says that you assign, you can say every point a different cluster, then based on their distances, their similarity metric, you can define your own similarity metric. You can use simple Euclidean distance, you can take absolute distance, you can use correlation scores, you can use mutual information. So similarity metric you can define as per your application. So how the basically clustering happens here, you just every step you just have a group of clusters to try to merge the cluster. So idea is you have every member is a different clusters. So if you have n data points, so you have n cluster in the data first, then based on the closest or closeness you just try to group the clusters, then you just compute the mean, again try to group and so on. So this way you can come up with a depth. So depth you can define up to how many cluster you want. So that defines the height of this tree, this hierarchy you can say. So the name is very popular algorithms are there. These algorithms are very popular standard algorithms. Okay. So I think before moving ahead, I want to give you one motivational example today. This is a very hard attack basically. We have mentioned here very simplest one, because I do not want to make you basically right now very current state of art. I am not going to use here that code, so that might incur certain issues, but I am just giving you the idea. So this is the Trojan idea that we are giving you here, and some now I can say some very simple basic approach will show you in today's demonstration, where you can design the attack. And this attack is very simple. So I will send my model to you for training purpose. You will train the model, you will send it back to me. I am assuming that you do not have access to the model parameters. You know the architecture, but you do not have access to the parameters. So this is the setting. If you have access to the parameters, then maybe this attack can be defended in some sense. You can find out this malicious code inside the code that we have written. So that's why I am saying that you I have sent you model in a way that you just supply your input data, and I will say certain guarantee that I will not share your data, I will not collect your data, but actually I am not true, I am not honest in that direction, but you rely on me, you have basically trained the model and you have sent it to me. So that is the system here. So idea is you have a training data, you have a model, here we have a Trojan module we have inserted, and this is a very simple module. We have a simple matrix. So whenever you are sending a data, because training is done sample by sample or batch wise, so whatever data you are using for training, we are scraping in this parameter. Only the thing is that the size basically will model size will increase, because you have additional unit to basically store this data. and the size that will increase is same as the size of the data. Okay. So, based on the model size, maybe some expert can estimate it. So, this attack can be you can find that there are attacks in this model. So, some Trojan module or some problem is there in this code just by comparing the memory consumption. So, initially the model that you have, what is the memory, and when you are sending it back, what is the memory. So, they must be similar in nature, because whatever data type you have already defined, right, must be similar, right, because the parameter, suppose you say that one parameter you have in your model and that as a float data type. So, you know that how much memory your model will take, right. Only one parameter you have to store. But when you are training the model, after the training the model size becomes very huge, because of we have scraped your data set inside that, but you do not know. So, just by comparing memory you can just try to identify. But suppose I say that okay, instead of 80 bits memory, that maybe 8 byte I am just taking for the float let for time being, maybe 10 bytes. So, 80 bits memory we need. Suppose we add one data type, one more variable. So, it is around, you can say 160 bits we need, right, memory. So, you cannot identify that one, right, easily. But if you say that instead of 160 bit, the memory required, or you can say the memory consumption is around 1 KB, 2 MB, right, 5 MB, then of course, there is certain things inside the model that is doing, right. So, in that way memory is, by scraping the you can say RAM, you can try to, you can basically mimic that attack, right. But suppose we are just adding some small memory, we are saying that we will not scrape your whole data, we will scrape only few samples in order to just see that what type of data you have. You just do that, and we have adversary, they can be trained on your few short learning, we call it, basically on your samples, and we will be able to generate the data, right. So, this is basically privacy attack, what kind of data you are providing to the system. But here in this attack, you know the exact data, because you have scraped whole data, right. So, this is one of the attack. So, in this attack the assumption is that the client, the genuine person, is not does not have access to the parameters, and they are not very, I can say, expert in that learning process. They know that we have model, we have to provide the input and we have to train it and then send it to back, right. But here in the same module, Trojan module, so you can design such that no one can identify it, even the person is expert, right. If you do not give access to the parameter, so in this setting you can design a Trojan which cannot be detected, right. You need lot of things to basically do, you have to compute the, so that is the many countries, even in our countries, in cyber physical system, we have lot of projects where what they are doing. So, you have a device driver codes, right. So, device driver we generally install on our machine. So, device driver, or you are installing certain patches or apps, right, any software that you are installing on your laptop systems or IoT devices. So, if you go and you just analyze the binary codes, executables, right, and looking into the binary code, if you are able to get that Trojan is inserted in this code, then you will detect the malicious part of from that, and you will declare that this code is basically Trojan injected, or you can say Trojan infected. You just avoid to install that, and you can basically, if genuine company is there, you can file a case and lot of things can happen. But that is a very complex part, analyzing the binary code, because you have only the executables with you. People do not share the parameter list, right, actual model they do not share. So, they share the executable, so that you can, if you want to scrape it, you can just only get the binary codes. So, have you basically displayed, have you seen the executable code, anyone? So, .exe in Windows, maybe in Linux we have many types of files, executable files. Have you seen any binary code? C language, I think everyone have studied, right. So, if you write the code in C, so your executable file is there .exe. So, have you displayed exe? So, now today's task is that in in the interval time, right, that we have a huge gap, just download any executable and try to just see that what is the content. So, there are tools like Hydra and some other Idea Pro. So, they try to basically mimic, they first identify this binary patch, binary, they represent your executable basically in binary language 0101. Then they have lot of things to do, basically you can come up from executable to higher level language. So, from binary code they try to build the assembly code, then from assembly code they try to build the higher level language code. And then once you have a code with you in higher level language, so maybe expert programmer, expert designer can understand it, right, and then they can find that this is the adversary, this is the attack, this is the Trojan part. But the thing is that many times this process is lossy process because of the architecture ISA, different system that you have. If you have different processor, for example, you have AMD, with different version you can say you might have Intel processors, right, and maybe some other processors, Snapdragon, right, or you can say some other maybe IoT processors you might have. So, they have different ISA instruction set architecture, right, and they have defined number of bits for every instruction. I think if you have studied the computer architecture, right, you know that, and based on that the binary code you have to analyze in order to represent the binary code into assembly language, then assembly to higher level. But some people are doing it, they are analyzing this malicious patches using these some of these tools, Idea Pro and others. There is an open research problem, by the way. You have a binary code, you have to just identify the malicious part or malicious piece of code in that binary patch, and it can be inserted anywhere, right. So, only a right time or right thing happens, then these codes are basically activating like function. So, when you call that particular function, it will execute, right. So, the similar process is there. So, among many bits, millions or trillions of bits, bit file, you have to identify maybe some 100 bits which are malicious, some 500 bits which are malicious, right, because they have the similar pattern as your legitimate instruction set is there, right. Many times it is very hard to identify. So, that is why the research is there in CPS. If you are able to identify, if you have some algorithm, some heuristic in your minds, right, you can come up with a good article in highly reputed venue you can publish. So, here we will discuss this one. So, we will show you that we will train it a model, and whenever I will send model to someone, so person is able to retrieve the data, right. Even you can do it in inferencing time. So, you can put this scrap module, right, that whenever you are sending any data to your model, you just scrap it. So, idea is, you know that in Python we have a list right, data type, abstract data type, right, list, tuple, dictionary and set, right. You have 4 such abstract data type, like in array C language you can say vectors in C++. So, what you do, just say that you just use the list data structure, maybe later on you can use some better data structure. So, what you do, just whenever data comes, you just append it, just keep on appending. So, until unless you have memory, do not have exceeded the memory, you can store it, right. And you can put certain module that how much samples you want to store, right, at a particular point of time. You just limit it, and you can scrape. So, scraping can be done at any point of time. It can be done at learning time. So, during the model. So, most of the attack are basically designed at the learning process, during the learning process. Some attacks are designed at the inference. Right. And mostly machine learning is a service model where you can say MLS, right. So, in machine learning as a service model, so most of the attack are at inference time. You have certain app which basically allows you to do something. So, for example, let chat GPT. So, you have only access to the interface, right. You just send the query, it will respond you. You do not know that how it is basically working inside, right. So, you do not know the architecture, you do not know the parameters, right. But what you can do, you can send your query, you can get response. Most of the ML as a service model are doing the same thing, like Gemini, you just go, just put query, get response. But suppose you want to mimic that model, we want to say that we want to come up with a equivalent model like ChatGPT or some other model that are hosted as a on cloud, right, ML as a service. So, what can you do? So, just try to generate the basically supervised data. So, here there is no need of any expert, you just put query, you will get response. You just try to collect it, scrape it, queries and responses as much as you can, because you know that number of samples we need more. How much it depends, right. Scrape the query and response data and just try to come up with your own model. You just learn another model which can basically minimize that loss. So, when you put the query, so it gives the similar response, right. So, this attack is called cloning attack, right. So, if you have unlimited access to the model, you have given unlimited access to the model. So, we will keep on sending the query, keep on collecting the responses, different type of queries, different type of responses we try to collect, and then we come up with our own model that might not be exactly same, but we can come up with equivalent model. And like DeepSeek, we say that okay, we are giving we have put our model as open source, please come, and its accuracy is same as the commercial model available. So, that can incur huge loss to the industry, right. So, who has hosted commercial model, right. Sorry. So, one more attack I am just telling you today, so we will discuss all those attacks. So, idea is we have ML as a service, right. Model is hosted on cloud, but our aim is to just identify that on what data it was trained. We do not have this Trojan module inside the model, but even we want to just get that what data was used for training, right. We do not know even a single sample, but you have a model. So, can you get that information on which data it was trained? So, this is called membership attack, right. So, we want to identify that who were the members on which this model was trained. So, this is very popular attack, membership attack, right. So, another one is basically you have model in white box. White box means everything is known. So, model is as a file is given to you, you know all the parameters, all the architectures. Then you have a lot of flexibility, lot of attacks you can perform, because model is in your hand, whatever you want you can do. Right. So, most of the open source architectures are following the same thing. So, many attacks you can design on white box, you can customize the code, right. And only the challenge is that most of the commercial models, so around 99.9999% models are in black box setting. So, if I have model, so why should I share the architecture to you, right? If someone has model, because we want to commercialize the model. So, that is why people are not sharing only the beta version. So, that is somehow similar. I am just saying the similar to the cloning model. So, generally people release as a open source for free, right. But most of the commercial model ML as a service, they do not allow this service. They just say that okay, number of queries that you can ask, maybe you can say 1000 queries are free, but after that for every query you have to pay, right. So, if you are doing programming, you want to use their APIs, then you have to pay per query, right. Even most of the basically LLMs basically charges per word, right, per token basis. So, how many tokens you can get access. So, based on that they charge. So, there are many models, price model or you can say cost model available there. So, here in today's session our aim is to try to protect our model some sense, right. Another attack is basically you can say that you have a data and we try to confuse your model, we try to fool your model, bypass your model, right. So, what we do? So, suppose you say that your system works for the face recognition system, a certain person or particular person is allowed to enter in certain critical zone. So, we just try to see that what type of features it needs for authentication. So, we will just try to tweak that feature and we can get enter to the critical zone. So, that is the idea that adversarial samples are doing. So, we generate a sample, it depends that what kind of problem you are trying to solve. So, we generate a sample which basically bypass the authentication system, or you can say decision making system, or you can say your machine, right. So, suppose you say that you have a sentiment classifier, you have sentiment classifier, you have one sentence and it says positive sentiment, right. Let you say that today the weather is pleasant, right, and your sentiment is positive, sentiment the model will tell is positive. Let I know the model somehow, we know the features that on which basically decision is made. So, you might think that pleasant might have a high probability towards positive sentiment, right, because the same sentence can have that today the weather is harsh, right, that has a negative sentiment. But we have a sentence that today the weather is pleasant. So, pleasant basically drives the whole decision making right now. We know that pleasant is a very important basically word or feature to decide this. So, what we will do? So, instead of pleasant we will put another word which might not be in the dictionary of that vocab, because you have to design the dictionary where you are basically pre-processing your data. Let I have used the word today the weather is maybe some synonyms of that word, right. Let good feeling, yeah, good looking or shining you can say. So, any semantically equivalent word you just put which might not be in the dictionary during the training process. Now, when you put this sentence in your model for prediction, so because that word is not in the dictionary, so your system will say let negative sentiment, right. So, you have bypassed the model. Actually, semantically your sentence says that it is basically positive sentiment, but because you have changed the basically equivalent or you can say semantically equivalent word or feature, you have changed little bit and your model is saying that this sample belongs to negative class, right. So, that way that basically adversarial samples are designed. You have image data, you just identify the locations or what are the pixels, what are the group of pixels basically important or drives for a particular class, right. Suppose I say that you have a digit recognition data, right. So, all the data set has digits only 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, just given an image you have to identify whether 0 is there, 1 is there, 2 is there, right. So, you have a model, somehow we try to get the access that what are the features in these images, that is it is basically model is basically taking and deciding upon. So, for 0 let you have certain features, for 1 you have certain features. So, what we will do, we will try to perturb little bit the image such that if you have a 1 in the image, it starts saying it is 0, right. Then you can basically you can bypass the digit recognition system, or you might have some AI module installed for automatic vehicle registration right, registration database system. Suppose you have installed your some camera, and at the back end you have this code that whenever a vehicle come, it basically get your vehicle registration, and it enters in the database that you are entering at the gate and exiting. But if you have a malicious module like this, so what might happen? So, it can be full, the system can fool. So, your maybe vehicle number is 24BH0659E, it might say 9 can be treated as 0. So, it will register 650, right. And then you know that once you have fooled the system, you can perform you can conduct lot of things, bad or good, that you want. So, that we will discuss today. So, these are the two type basically two type of attack generally happen in machine learning, or you can say in AI systems. One is this during the training phase, I already told you. Generally, we will put Trojan, we play with the whatever code, whatever algorithm we have, right. Because whenever you are designing any attack, right. So, we are prepared that someone will come and they try to defend it. So, we have to design attack such that most of the possibilities cannot be used, most of the solutions should not should not be able to defend it, most of the standard procedures. So, someone very you can say expert of that area, they might get it, but if your attack is successful about 60-70% or 50% or 40% even, this is significant, right. Attack is significant, right. You know the pager attack. So, around 2000 people or 3000 people were affected by that attack, right, that Trojan attack. Even you can say the percentage wise, how much population was, what was the percentage of the population that was basically affected by that attack. It might get to very few, right. If total population is that 1 million people, or you can say 10 lakhs people in the country, and you say that 2000 people have got affected, it is very less, but statistically it is less, but significantly it is very huge. So, even 1%, 2%, 3% attack rate is very huge. So, here we will see that if your attack is successful maybe for 20 or 30% or 40 or 50% time, then it is very huge, right. So, it means that out of 100 samples, 40 samples are bypassing the system, right. You see the probability then. So, here the idea is change the labels to training inputs. During the training process, I have already told you that you can mislabel the data. So, once you mislabel the data, then your model, you know that because you are the attacker, you know that your model will be corrupted, your model will not have correct information. That is why you can say that most of the model that use the adaptive learning, that follow the adaptive learning system, generally the models basically scrape data during time. For example, ChatGPT type models, so they scrape your data, whatever query we are asking, and whatever response we are going basically giving. Suppose we have performed one query, response is not good. So, we generally write, they have like and dislike symbol. So, you can like it, you can dislike it, you can provide your comment there, right. So, based on that they are basically scraping our data, and then based on that they are retraining the model. So, if suppose it is at the local end, or you can say local, everyone is trying to basically retrain the model, then model can be corrupted. So, we will put the corrupted data. So, if model is saying it is sentiment is positive, we will say that no, sentiment is negative, please learn it. So, model will try to tweak its parameter values, right, so that whatever query we are asking and relying on me, it will say that okay, this is negative. So, then you try corrupting the model, and lot of companies are there. So, they are in competition and they can deploy many influencers, many people, they can crowdsource this activity and model will be corrupted within a day. So, that is why this model does not allow that retraining. So, every time, or you can say at local end. So, once they scrape the data, they basically try to identify the type of the data. They have certain statistics like clustering you have, and many other things, keyword based collection. So, if you see that on Google platform, if you write certain file names like attack or malicious or something, so they will send warning that you are performing malicious activities, right. So, this is happening, right. So, if you just store your file name or some keyword is there in your file that talks about the malicious, corruption, right, attacks, or you might say some other explosive words, right. So, even on Google search engine, if you try to identify, try to search something like how to make certain explosive objects, right, I am not going to take the name, right. So, they basically record an activity and they just send an email to you, or maybe the organization from where the email basically that belongs, or many times they can block your email. So, that is happening, right. If you want, you can check, but remember that your mail ID might be blocked. So, that is the thing, right. People industries has certain mechanism to identify, and many times you can say that unlimited querying is not possible, they have limit on that, right. So, otherwise you can scrape data and you can come up with a equivalent model, right. So, this is the process generally happen. You can see the block diagram. So, you have a training data, you have malicious samples at the time, you can build the model. If you say that whether your output whatever you are basically interested, right. So, if your model is saying yes, so S is poisoned information. So, it means that corrupted output you have got the bad response, but you do not know, because we are relying on the model. If model says this, then generally we say that this is the true story. If you do not know the ground truth, if you know the ground truth, for example, in ChatGPT, if you ask certain query, so suppose I say I just ask what is the capital of India. It says suppose you do not know India, you never studied history and all other things, geography and others. So, suppose it says Kolkata. So, you will rely on that. You will say ChatGPT never tells incorrect thing. You will rely. But if you know the ground truth, you know the capital of India is Delhi, then you will see that model is not giving correct response, right. So, that is why here I am saying that if you have deployed your system in real time, you do not know that what is the ground truth. If you know the ground truth, then there is no need of any model. We already know that, right. So, what is the need of deploying any model? So, model need is that you do not know the output, you do not know the basically values. So, it will predict you something. For example, weather forecasting, if you know that tomorrow will rain, so what is the need of any AI model or machine learning model, right? Because you know tomorrow will be rain, so you will have umbrella and you can accordingly you can plan. But because there is uncertainty, you do not know. So, you want to come up with a model which can give you the you can say better justification or better prediction, and every time you can say that it is written that 90% chance for raining, 90% for clouding and something like that. So, accordingly we generally plan. So, here it will give the output and that output will be poisoned. So, this one will discuss this attack, right. We will see that during the training process we try to somehow attack the system. Then few attacks are there, the once you have trained your model, now we are trying to attack. So, we have already told you that membership attack, cloning attack you can perform on that. And for cloning attack, the current state of art is the GIAN based attack. Generative AI models you can use to perform the cloning attacks, and of course, the generative AI approaches people are using for membership attack. So, both will demonstrate, maybe GIAN based attacks will demonstrate tomorrow's session. Today we will discuss about the just adversarial sample generation using some standard neural network, not the basically GIAN based architectures, some different gradient based approaches, and thus simplest approaches we will discuss today. So, where you just have a data, you little perturb it, you just try to identify the what are the features, dominant features on which the model basically decides certain thing. So, only we will try to get those features and we will try to change those features, we will try to corrupt those features in order to bypass the system, in order to fool the system. Right. So, training one is a training phase, another one is real time or testing phase when your model is deployed in real time. So, this is this thing here, because just generate new sample, you have a model, desired output that you are attacking. So, this is called basically targeted attack system. So, you say that given any input you want to target any digit, if you just input, we say that okay, we want to predict in certain class certain digit. So, whether you are giving input 0, 1, 2, 4, 5, 6, 7, 8, 9, we have to say that any image that you are giving, it should be classified as 4, right. Any digit you just provide to the system, we want to design the attack such that your system will say it is 4. This is called targeted attack, right. We want to generate a sample which is classified or which can be assigned to a category, already target category or you can say designed category that we want, that we are interested in. So, that is called targeted attack. Untargeted means it can be assigned to different class, any class, but not the actual class, actual digit, right. So, targeted attack are little simpler. So, you can design a very good loss function. Even those non-targeted attack are also basically very popular, you can design. So, in today's session I will discuss and you will be able to design these type of attacks, right. So, you can bypass the model in this testing phase. So, you have a trained model, you just the assignment will be that you just train your model, then you try to perform the attack. So, idea I said that most of the model uses loss minimization, right. So, strategy gradient descent approaches to minimize the loss function, right. Most of the algorithms uses, starting from the support vector machine, we try to minimize the objective function that you have, quadratic objective. Neural network we try to minimize the loss function, either mean squared error if you have a regression data, maybe cross entropy if you have a classification or category prediction data. So, you just compute the gradient, because gradients are used to learn the parameters. So, we will use the gradient to identify which features are important for this decision making, right. So, what you do, you have a loss function, compute the gradient with respect to the input, with respect to the input, you know that what feature in the input basically changes this gradient information significantly, just record it. So, in the input data now you know what features are important for deciding particular class, you just focus on those, you just try to corrupt it little bit, right. Suppose you have a text data, you try to basically change the word, change the just replace that word with its synonyms, that is called synonym based attack. Maybe because semantically it is meaningful, right. So, attack is like this, it looks similar. Actually, if human try to basically understand, so it looks similar, but it is basically fake sample, fake input, right. So, that is the idea behind this adversarial sample, adversarial examples. You just try to change it, your decision, the model's decision basically changes, right. Suppose you have an image, you just change 2 pixels, you have a let 1 megapixel image, you just change 2 or 3 pixels, it does not matter, but decision of your model changes. Earlier it was saying that this image contains object let apple, but when it changes 2 pixels, it is saying banana. You have a face image, you just change few pixels. So, your face, original face is belongs to let person A, but it changes 2 pixels, your model is saying person B. So, it means that your model is not robust much, it is susceptible towards certain noise, certain perturbation. So, we will see the capability of the model and how can we do certain arrangement, you can say certain trade off or certain compromise between this adversarial sample generation and developing a robust model. But of course, it is always possible, right, it does not matter. So, on any system, so this attack is possible, you cannot prevent it, right. Some attack of course, it will be there. So, you can generate adversarial sample which can do harm. Yes. Unless until, so we have lot of measures we will discuss in today's session. So, you can come up with the research article on that, because many of you are PhD students and faculty. So, you can think in that direction, and UG student can take projects by the way. So, codes are available, you can just try to just little improve it, right. So, generally we call it evasion attack. So, this is the process here, you just keep on doing, keep on generating the new samples. Once your model is able to be successful, if you say that okay, whatever sample you have generated, the model is saying it belongs to certain class, right, maybe class 0. So, it means your attack is successful, and this sample might be looking as your distribution, or you can say original distribution, it might not be. You might have a garbage looking sample, suppose image data I am just talking about. If you see it is garbage, you cannot, human cannot understand anything, but when you fed this image to the model, it will start saying that this is 0, right. So, that is the adversarial sample generation, you can generate it maybe by adding certain noises, by learning certain, by minimizing certain optimization functions. So, we will discuss those. Then these attacks we have already discussed, the white box attacks, black box, grey box, right, that is the idea. Targeted attack we have already discussed, that your aim is to basically design samples for which model says a particular class, right, particular category,